We, the students of GRIT, have done a project named Wireless Joystick Control Pan and Tilt Mechanism. The main aim of the project is to control the pan and tilt mechanism wirelessly using joystick. The pan and tilt mechanism mainly consists of two servos. To control rotation in horizontal plane called panning and in vertical plane called tilting. The pan and tilt mechanism is used for positioning sensors like camera, antenna, etc. This is a project module. The wireless communication between transmitter and receiver is done using Zigbee protocol. Zigbee protocol is a simple wireless protocol used in applications which require less data rates and low power. Coming to the project setup, it consists of two blocks, transmitter side and receiver sides. Transmitter consists of three modules, namely joystick shield, Arduino shield and Zigbee shield. The joystick is to provide analog input and UNO is to process analog input and convert into corresponding digital signal, and Zigbee is to transmit the digital signal wirelessly. Similarly, receiver consists of three modules, Zigbee shield, Arduino UNO and servo shield. Here, Zigbee module and Arduino UNO do the same job as it in the transmitter side, but in reverse order. That is, Zigbee module receives the digital data transmitted and it gives to Arduino UNO, which process it and convert that voltage in terms of angles and give it to the servo shield, which controls the two servos of pan and tilt mechanism. Now let us see in detail about operational features about each module in the block diagram separately. Coming to the joystick sheet, this mainly provides push buttons and thumb joystick. The joystick is really two potentiometers that are linked to handle, which can be moved either in X and Y directions. Based on this X and Y directions, the corresponding analog input voltage will vary. These analog values range from 0 to 1023. This is because the Arduino has a 10-bit A to D converter. The first range, that is 0 to 511, is used to represent input voltage in X direction, and second of 512 to 1023 is used for representing Y direction. These analog input voltages are transmitted to Arduino UNO analog input pins A0, A1. Coming to the UNO board, the Arduino UNO is a microcontroller board based on the ATmega 328. It has 14 digital input-output pins, 6 analog inputs, and it is a 16 MHz crystal oscillator. The Arduino can be powered via USB connection or with an external power supply. It has an internal 10-bit ADC which automatically converts the analog input voltage to a digital data taken from a joystick. It has two serial pins 0 and 1, which are used to receive and transmit serial data respectively. Coming to the Zigbee module, this module mainly consists of Zigbee shield. Zigbee protocol is mainly used for wireless communication between transmitter and receiver. This is serially interfaced with the UNO board. Zigbee shield mounted on Zigbee module acts as transceiver. That is, it can transmit as well as receive. In transmitting side, this module receives data serially from the UNO and it transmits wirelessly. Whereas in the receiving side, this module receives data wirelessly and transmit the data serially to UNO. For serial communication between UNO and Zigbee, transmitting pin of UNO is connected to D-in pin of Zigbee module and receiving pin of UNO is connected to D-out pin of Zigbee module. Zigbee module in the transmitting section acts like coordinator node, whereas in the Zigbee module in receiving section acts like rotor node. Coming to the servo shield, the simple lab servo shield is designed to drive the servo motors. Servo motors are the DC motors with accurate positioning capability which ranges between 0 to 180 degrees. This shield can be drive up to 10 servo motors. In Arduino programming environment, servo.h library file is used to control servo motors using microcontroller. Each servo motor is having 3 lines: VCC, ground and control lines. The control line is directly connected to microcontroller. The digital voltage given by the joystick shield is converted by the UNO into corresponding angles and given to the servo motors via servo shield. The servo shield is powered by an external battery backup. Coming again to the panel tilt mechanism. As said earlier, it is a sensor positioner. Out of 2 servos, one servometer is fixed to the lower bracket to control the rotation in horizontal plane, and other is fixed between the 2 brackets to control the rotation in vertical plane, which is called panel tilt as said earlier. Now let us see the operation of the system. This is transmitter section. In this, the UNO board is powered via USB connection. The Zigbee module is placed on the UNO board and the joystick shield is mounted on the Zigbee module. Based on the direction of the thumb joystick, the analog input voltage is generated. This analog voltage is sent to the. Now let's see the operation of the project. If the thumb joystick is moved in X direction, then the pan motor is rotating. If the thumb joystick is moved in Y direction, then the tilt motor is rotating. Thus, panel tilt mechanism can be operated wirelessly using joystick. This setup can also be used to control the CC camera wirelessly and to change the direction of antennas as per the requirement.